Many institutions believe they are implementing blended learning when they replace chalkboards with smartboards and physical textbooks with tablets. But if the rows of desks and the teacher's central position remain static, the underlying educational model has not changed. Utilizing electronic whiteboards or online textbooks in a traditional teacher-led lecture is simply a technology-rich conventional setup. The Christensen Institute provides a rigorous distinction. True blended learning is a formal education program that requires online delivery combined with a supervised brick-and-mortar location. The core defining variable is control. Blended learning transfers authority over time, place, path, or pace directly to the student. Misdiagnosing this definition is costly. When administrators confuse digital tools with structural change, they pour capital into an obsolete factory model rather than innovating. Building a successful blended environment requires treating it as a holistic engineering discipline, rather than a loose collection of software tools. The first architectural layer required for success is a rigorous structural taxonomy that dictates how time and physical space are allocated. The second layer is a pedagogical engine. This governs the psychological and social dynamics of learning within that new structure. The apex layer is the AI native frontier, which uses empirical data to leverage adaptive algorithms for individualized instruction. Only by intentionally aligning structural modality, pedagogical theory, and intelligent technology can an institution unlock the true value proposition of a blended model. We can divide blended learning models based on their disruptive potential relative to traditional classrooms. This flowchart maps the hybrid zone of blended learning, formats retaining traditional master schedules while adding digital elements. On the left are rotation models, station, lab, and flipped classrooms. Here, students rotate on fixed schedules between online and face-to-face modalities. These are classified as sustaining hybrid innovations. They incorporate new technology to optimize and enhance the existing factory-based classroom system without destroying its architecture. While these sustaining models are the most accessible and least risky for traditional institutions to implement, they ultimately cap the potential for radical personalization by keeping the standard daily structure intact. To break that cap, we move to the right side of the flowchart. These models depart completely from traditional classroom architecture. In the Flex model, online learning is the backbone. Students move on fluid schedules, guided by mastery rather than a clock. Similarly, the enriched virtual model discards daily seat time requirements entirely. Students complete the vast majority of their coursework remotely, returning to the physical campus only for specific, required face-to-face enrichment. These are disruptive innovations. They diminish the student's total dependence on a human teacher for direct content delivery and standardized pacing. Choosing a disruptive model forces a complete institutional redesign. It requires new concepts for physical space, faculty utilization, and academic accountability beyond the standard credit hour. A disruptive physical structure cannot succeed without a proven pedagogical framework to drive actual knowledge construction. This diagram illustrates the community of inquiry, the established theoretical standard for evaluating blended learning. Effective educational experiences require the intersection of three presences. Social presence builds group trust, cognitive presence fosters critical inquiry, and teaching presence dictates instructional design. Empirical data shows that blended environments achieve group cohesion and higher order inquiry significantly faster than environments that are 100% online. The brick-and-mortar component of blended learning operates as a necessary catalyst. It accelerates the social and teaching presences required for deep cognitive presence to occur in the digital space. A massive systematic review of higher education studies published between 2020 and 2025 reveals how artificial intelligence quantifiably improves academic performance and engagement within this architecture. This chart visualizes the most prevalent AI applications in blended environments. Intelligent tutoring systems at 27.7%, chatbots at 23.4%, and adaptive learning platforms at 21.3%. Tutoring systems show a significant impact on learning outcomes, producing effect sizes between 0.58 and 0.89. These high effect sizes are generated by an operational mechanism known as the additive model of deployment. In this model, AI functions optimally when its automated feedback precedes a physical class. This allows the human instructor to bypass basic content delivery and immediately target the specific, complex misconceptions the algorithm has already identified. A truly mature blended environment synthesizes all three layers: a disruptive physical structure like the Flex model, driven by community of inquiry pedagogy and amplified by an intelligent tutoring system. Deploying this architecture is constrained by severe institutional barriers, highlighted throughout the empirical literature. This table outlines the specific challenges threatening successful AI integration. The primary barriers are a lack of instructor AI literacy, strict data privacy regulations, and the persistent risk of algorithmic bias. Furthermore, the rise of generative tools means traditional, detection-based approaches to academic integrity are insufficient. Institutions must execute a complete reconceptualization of assessment design. Procuring advanced software yields zero return unless the institution commits to continuous evaluation, robust ethical frameworks, and targeted professional development for educators. Blended learning requires an intentional architectural shift, not a simple digitization of the classroom. Despite anxieties regarding automation, the data proves that current AI systems cannot replicate the affective and relational dimensions of learning. The face-to-face component of blended learning remains a qualitatively irreplaceable function that mediates the efficiency of the digital backbone. True mastery of blended learning lies in engineering an ecosystem where human-mediated relational instruction and adaptive digital algorithms do not compete, but directly amplify one another to enable personalized instruction at scale.